Transformer, this website. You click on that. I will just share my screen. Yeah. So this is the site where you will come. Then you have to download this 321 MB software by clicking download now. And once you download, you should be in a position to see this file pro demo. Whose size is 321 MB. I have already shared this file onto your files in the, so hopefully it will get uploaded soon. So you can download it from this particular file section from your Teams also. So it's now uploaded and you can download it now. So either way, you download this setup and then double click. Since I have already installed, it will show me different options like remove or update. But since you have not installed, you will get this particular window. Click next. Now here you will get a new installation. So for me it will be just same. So I just go ahead and then you can install this. So pretty straightforward software installation. Proteus is the software that we are going to use for this lab. This lab has an exam component, so please focus and do all the student serious. So once you install, you have to come to this Proteus Professional app. I think it got moved or something. Let me just check. Okay, you have to click on this Proteus demonstration, and version 8.6 is what you'll get. I have also shared another link by which you can download the cracked version, but I would refer you can continue with the demo version. No issues with that. Only problem with demo version is you cannot save the files once you do it. So you have to take a print screen before it shuts down. So anyways, all your submission do require print screen. So whenever you run an experiment, take multiple print screens. I hope the Proteus is running soon. So this is how the front window of Proteus will look like, and let it open now. So yeah, it is getting downloaded for me also. I just cancel it. Hopefully it will open soon. I don't know. Okay, so then you have to click on new project from here, new project from this side. So for the experiment number 1, we are going to study the Ohm's law, and then we will simulate some of the digital gates. Go to the new project, click on next. So I have already created something. Click on next, click on next, click on next, and then finish. So this is how the software will look like. Now, since it should be a practical lab, but because of this lockdown, we are taking it online. So this is the, what you can say, best simulator which is closest to the reality, and whatever will happen practically will be shown in this simulator. That's why we have chosen this Proteus simulator. Even though it's a demo version, it will allow you to do everything except you will not able to save anything. So conducting a lab is possible. Make sure that whatever you do, take a print screen. So let us understand this software. First thing you have to do is go to the component mode, click on place the components. Now for verification of Ohm's law, we will need a battery. So I just type bat, and then I can go to the miscellaneous, and then I can choose a battery. So press enter, place the battery using a mouse. So by default it is a 9-volt battery. Now you can double click on this to change the value of this to 5-volt. So the battery is now 5-volt battery. Now why 5-volt I will tell you later, but for Ohm's law we just need one resistor to prove V is equal to IR. So let's go again to the components, go to the place and type RES resistor. and you will get some resistor. Press enter, and then you can place that resistor. You can right click and rotate that resistor 10K, that is okay. Next thing is making a connection. So when you bring your mouse close to the terminal, it will start glowing, okay, and then you have to just drop it to the other end, that's it. And again when it glows, just click again. That other terminal of the battery should be connected to the resistor. So this is a complete circuit. Now each circuit do need a grounding, so grounding is available in terminal mode. Go to the ground, select a ground, place it, and then connect the grounding. Now next thing is V is equal to IR. So we know V, we know R. We need a current measurement unit. So all the measuring instruments are here. Here you have oscilloscope, logic analyzer, timer, counter, I2C debugger, etc. etc. Now this is a DC and we want to measure a current. So I will choose a DC emitter and place it somewhere here. So now next thing is you want to connect and you have already done some connection. So you can right click and click on delete wire. Select a new connection, check the polarity, otherwise you will get a negative sign on your current meter. Now it is logical that if you are using 5 volt and 10K and you are using V is equal to IR, the current won't be in amperes. So what you can do is double click on this meter and change its unit to milliamperes. So I think the current should be around something around 0.5 milliampere, and that is what we are getting here. So 0.5 milliampere into 10K should be around 5 volt, which proves the Ohm's law. Now let us go to our actual experiment one. So again, experiment one write up should be there somewhere in the downloads. Let me just check. Yeah, study of the basic gates. So I will share this write up with you on the drive as well as this meeting upload. Okay, you can download this drive, simultaneously start downloading Proteus software. So the experiment one is about logic basic gates. We have already studied these gates in our lecture. So if you have missed that lecture, you can go to YouTube, search for Dr. Delay, I guess, and then you should able to find all the lectures. Yeah, lecture one, industrial electronics. So you can go there and watch this lecture if you have missed it, and all the lectures will be made available to you. I will give you the website link for that also. So this is about the gates, gate 1, gate 2, gate 3, all these truth tables we need to verify, gate 4, gate 5, and then this special gate 6 and 7. So the first diagram is not gate, which I will ask you to do it. We will start with the simulation of AND gate. Let us relearn the software. So what I will do is I will just remove everything and let's start fresh. So you will land up on this screen. When you start, you can zoom in, zoom out using scroll of your mouse. First thing for this circuit, first you observe the circuit. You need two batteries. Okay. Now one more source of battery is over here inside a generator. You can have a DC source like this. You can place it, and this can also act as a battery. Double click on it and say 5 volt DC. This is another way to generate a DC source. But right now we will just take battery. So I just remove this, go to the place component, go to the place, type BAT, then go to the miscellaneous and select the battery. Okay, once you do that, you have to place your battery. Since we are studying a digital logic, the output has to be 5 volt logic 1 and 0 volt logic 0. So that's why I changed the battery rating to 5 volt. Practically, you will never get a 5 volt battery. You can get 4.5 volt or you can get 6 volt battery. So I have just placed a 5 volt battery over here. Even for your mobile phones, you get 3.3 volt battery, not exactly 5 volt, but there is a circuit that converts this 3 volt to 5 volt. We might study that later in the course. So right now just assume there is some source of 5 volt. Let's replicate this. So there is no point in doing same thing again and again. Just click on this arrow, select the entire ring, right click, then say block copy and just move it and paste it again. That's it. You can make multiple copies of the same. So I just escape this. Now next thing is we need to place a grounding. So what I will do is click on the terminus mode, select the ground and place it. Okay, now next thing is connect it to the ground. We need, if you see the circuit diagram, we need two switches, one AND gate, two resistors and one voltmeter. So let's find out all those things in the place component. Go to the component mode, then click on place. Sometimes you go and click place somewhere else, so you don't get this list. Next thing is you need AND gate, so just type AND. You'll get multiple AND gates. Which one to select? Generally take AND, which is active, to input AND gate and press enter. So this is the AND gate that we are going to verify with the whatever we have been taught, whether it is actually like that. Next thing is we need a voltmeter, so come to the sources, meters, and come to the DC voltmeter and place a DC voltmeter. Connect it to the ground, negative terminal, and positive terminal to the output of a AND gate. Next, again come to the component list, go to the place, and here we need resistors. So type RES and then you directly get RES, which is a resistor, generic resistor model. Click OK. You can also right click to rotate, and that's it. Your resistor is placed. You need two of them. So what I will do is again select this, right click, block copy, paste one more. Now if you want to change any of the values, what you have to do is double click on that particular resistor. Okay, don't double click on the strings. Okay, you want to change the property of the component and not its strings. Okay, so even I can write this string R2 as, let's say, 50k. Okay, so this 50k doesn't mean the value of resistor is 50k, it's the name for that resistor. So just don't change the string. Let me call it R2. And if you want to actually change the value, you have to double click on the component to change it. Okay, so instead of 10k, if you want 100 ohm, you can do that. Just click and now it becomes a 100 ohm resistor. So let me just change it back to 10k because in the experiment we need 10k. Next is we need some operatable switches. So go to the components again, go to the place part and type switch. I think switch should work. Then switches directly pop up. So you can select switch and click on OK. You need two switches, so one for the battery 1 and the other one for battery 2. Now we will make the final connections. Let us see the circuit how you want. Your first battery goes to the switch, then second battery goes to the second switch, and both to the inputs via a resistor. So let's connect this battery, switch, battery, second switch, then both the things goes to the input of the AND gate. And now any one resistor you can connect to the ground. So everything is ready. Let's run the simulation. So you can see everything is blue, logic 0, and that's why output voltage is 0. As soon as you close the switch 1, still output voltage is 0. But you see these dots have turned red. That means logic level 1. Now as soon as I close both the switches, the output goes high. and then if you open any one switch, it will become low. If both switches are closed, it will become high. So this is how AND gate works, and with that I will stop recording, and if you have any further doubts, you can ask. So you have to simulate the remaining circuits by your own. If you have any doubts during that, you can also ask.